just edit an existing one. For example, I can have this lab one that was a project for my private data center and for AWS, for example. I can add VMC as another cloud zone. How I do that? I go into provisioning, add cloud zone. When I do add cloud zone, I will select exactly the data center that I have in VMC. I click add, and here on the compute, this is interesting. I can create a capability tag to associate that directly to VMC. What can I do is just to select the clusters. Here, really important, remember on the VRA that I need to use the compute resource pool? Here's the same, or the compute resource pool, or the pools, or the sub-pools that are part of the compute resource pool, and then I create a tag. For example here, cloud VMC tag, okay? Next step is to add the flavors. I can create a new flavor, or I can edit a new one. Here I already have a small flavor that, for example, here I can see I have T2 micro for AWS. I have details for my on-premises implementation, and here I can choose, for example, 1 CPU and 1 gig of RAM for my small on what I consider on VMC, right? Next step, the same, really similar. I can have like a lot of image mappings. I have a Ubuntu mapping here. Then I can use a template that I have on VMC, right? And as I did on VRA, I have to create a network profile as well. So new network profile here. I will select exactly the cloud zone or the regions that I have. And then I will add the network, right? Here I can select the networks that are created on VMC, and I can edit and add more information related to domain, default gateway, DNS service, everything that I want to when I provision in this will have this information, these properties, okay? The infrastructure part is ready. We need to go to the design part. On the design, I go to blueprints, new blueprint, and I created here the name, VMC demo, and I choose the project that this blueprint will part of. Here, I can drag and drop vSphere machine, right? And on the right side, I can type my properties. For example, the image, remember, I'm using Ubuntu image. The flavor, I'm using small. And here is really important. Remember on the VRA, the custom property, here I have to do the same for the folder custom property. But here we can just type folder name and see workloads or a subfolder inside workloads, right? The number of instances here, count 1, and also the constraint for Cloud VMC that will entitle and force that to be provisioned on VMware Cloud on AWS, right? So with that, we can deploy. So I put here a VMC deployment name and hit deploy. With that, Cloud Assembly will start creating everything. We start provisioning this virtual machine inside VMware Cloud on AWS, right? So after a few minutes, I will have my Cloud vSphere machine with all the properties and everything that I did on the blueprint side, right? And here it took about, depending on the size of and all the customizations you do, this in case for me it took like 2 to 3 minutes to create this virtual machine, right? And just to finish this and to summarize, both vRealize Automation and Cloud Automated Service can be your automation platform for even private cloud, for VMC or any other cloud that's running VMware, and also public clouds, right? Of course, one, you have VRA, you consume that as on-premises with license-based. Cloud Automation Service is a SaaS solution that we have, right? with that, I would like to thank you very much, and if you have any other question, I'll be around here. Thank you.
Hi, my name is Susan Wu. I'm the Senior Product Marketing Manager in Network Services, Network Security Business Unit. I actually handle service mesh, and prior to this I was at CNABU for Kubernetes, and then many eons ago I worked at Docker and OpenStack and CloudStack. So actually I'm here to tell you a little bit about implementing persistence in Kubernetes. It's not for the whole Kubernetes talk because I only have 10 minutes. So there are a lot of sessions about Kubernetes that you can go to, a lot of Tanzu sessions. So this is only about implementing persistent storage. Very quickly about the applications. Architectures are changing. I started my life in Java, so it's monolithic. The whole team, I think 200 of us, all use the same IDE. We only check in code once a week, and then we have peer review, and it was pretty much impossible to kind of dictate the type of architecture that you want to do. And it's a little bit unflexible. We used to use the waterfall method, so we would code and then we would find something at the very, very end. And we've seen even showstopper bugs. But now, fast forward 10 years, about 2000-ish time frame, many companies started adopting microservices, smaller teams. They get to choose their stack and also their favorite backends, all of it connected with REST API. And so this is really changing. People can revise their application, they control that stack, they can iterate on their own intervals. That's kind of how it's happening. But in reality, not every application in the enterprise is in microservice pattern. VMware, we still have quite a bit in Java. We still have some LAMP. But we started moving a lot of our customer-facing services like myvmware.com to microservices. And so with that, moving to microservices is prompting the use of containers and moving to Kubernetes. We've been meeting a lot of customers, and generally they've been faced with similar problems before they adopted Kubernetes. They've had failed applications in production. They need a lot of lead time before they could deploy. And what was really common now that I'm in networking is they're looking for a common set of APIs to provision infrastructure, network infrastructure, and other infrastructure as part of even like a CI/CD pipeline. So just for the product that I work on, NSX, it actually exposes the REST APIs, and you might be familiar, that actually you can actually provision like a distributed router or a VPN, all using the REST API. So there's some sessions here where some VMware engineers coded Python Django, including the NSX APIs, and then show how to provision, auto provision the VPNs. And they also show doing that same cycle onto, say, VMware Cloud and also on-premise. And then they also use the same kind of pipeline technology to seamlessly connect their security policies on-premise as well as on the public cloud. So that's what's happening. So on Kubernetes, why